It's June 2023. I'm in Athens, Greece. It's a really hot morning, sun high in the sky, and I step off a bus at the airport. No, I'm not catching a flight. I'm actually attending the Specialty Coffee Association's World of Coffee Trade Show, which is taking place next door to the airport. And I'm here very early in the morning because later in the day, I'm going to be doing an experiment. I'm putting a question to the test. How is what's going on inside my head different to you when we taste the same coffee? Are we actually living in the same flavor universe? I began to come across a lot of genetic evidence, cross-modal evidence, cultural evidence that suggests when we drink the same coffee, we might actually be tasting different things. And so here, in this coffee trade show in Athens, I'm going to give the same coffee to lots of different people and discover whether they're actually tasting the same thing. But for this experiment to work, the coffee has to be the same. Which is why I walk across the trade show to the Marco Beverages stand. Marco is the sponsor of this episode, and I chose to work with them because they are a leader in making brewing equipment for cafes. And at the stand, I meet Rene Callis.
I'm a coffee guy through and through, and it just so happens to be that I'm in charge of sales and tech support in Europe for Marco.
Rene is going to help me brew up many batches of the same filter coffee. But here's the thing. It's actually very difficult to do this consistently. I explored in the previous series how there are so many variables that can make a simple pour over coffee quite inconsistent batch to batch. Temperature, time, flow rate. But Marco developed a solution to this, the SP9. It's a countertop brewer for cafes that automates a very delicately made hand-poured filter coffee. It delivers a very precise amount of water.
And the machine will divide these 500 milliliters into 9 different pulses.
In a very precise amount of time, because all the hot water first goes to the top of the head and then gravity takes over.
We use basically gravity, like a constant in the universe, to control the water flow, because we control the water.
At a very precise temperature.
And since the water always circulates between the head here, the cylinder, and the boiler, you always have temperature stability. So the temperature in the boiler...
Rene showed me how to make many pots of the same coffee on the SP9. And he was assuring me that all these brews would be the same. But I needed even more certainty. And so I decided to test these coffees with a refractometer, the device that measures how strong a coffee is. Shall we do a TDS measurement of each of these 3 coffees?
Oh my God.
And see
no pressure.
See how the SP9 holds up?
Yeah, absolutely.
Let's do it.
Yeah, let's do it.
And then came the results. Coffee number 1.
1.48. Yeah.
The first coffee had a TDS of 1.48. Basically, in this water, 1.48% of it has coffee compounds floating around in it.
Second one.
Second coffee. Here we go.
Then, coffee number 2.
You nervous?
Nah. 1.48.
Whoa. It's the same.
It's exactly the same.
And finally,
send your prayers.
coffee number 3.
Here we go. Oh my goodness. Oh.
Nah! 1.49.
I mean, in fairness, that's pretty
But
good.
come on.
Come on.
Now, I knew my TDS meter had a margin of error to it, so I did even more tests, and I was satisfied that every batch of coffee was going to be almost identical. And so much more consistent than, if Rene and I had stood there pouring this water out of a kettle ourselves, batch after batch.
And I mean, you would have to be spot on with your hands, which is almost impossible to do and to replicate that. So I think if, that's now 3 brews. If we did, say, 1,000 brews, that would still be spot on. But in 1,000 brews with a human being, you would see massive differences.
Okay, so I had many pots of the same coffee. And then, over the next couple of days, along came some Filter Stories listeners. I'd done a shout out on Instagram and a whole bunch of people had raised their hands saying, hey, yeah, I'd love to be a taste tester for your experiment. Even though I don't really know what you're going to do to me.
So today, we are going to be tasting some coffees.
And then I gave everybody an identical coffee.
So now we're going to the 79 ROG.
And I got very different answers.
I mean, it's sweet.
This is quite chemically.
There is a bit of orange taste, orange peel.
Maybe something green.
Dark chocolate.
Almost tea-like.
Woody astringent finish.
I mean, I couldn't believe it. How can this exact same coffee taste so different to different people? It was being described as sweet, chemically, orangey, green, dark chocolate, tea-like, and woody. I needed to know, is my tasting reality the same as your tasting reality? So, in this episode, to begin with, we'll look at your flavor receptors on your tongue and in your nose. Are my receptors the same as your receptors? Are we getting the same information? Then I'm going to explore cross-modal effects. Are there things in the environment which might change how you perceive coffee relative to me? The type of cup you're drinking it from, the music you were listening to. And I finish by looking into the muddiest, most complicated aspect of all of them. And that is our lived experiences, our cultural backgrounds. Are you ready for this? Because we're about to get metaphysical. I'm James Harper, and this is The Science of Coffee, a spin-off series from my documentary podcast, Filter Stories, and a journey into coffee's hidden, microscopic secrets. So, first question. Genetically speaking, are my smell and taste receptors the same as yours? Now, back at the trade show in Athens at the Marco Beverages stand, I did an experiment and got some weird results. So, I had brewed up many pots of the same coffee on Marco's SP9 brewer, and I was satisfied that they tasted the same. They were brewed consistently. But then, I added different types of artificial sweeteners. Now, you find artificial sweeteners everywhere. Monster energy drinks, Coke, you name it. But it turns out you and I could perceive it quite differently. For example, when I added the artificial sweetener stevia to coffee,
it's sweet, it's not bitter.
A group of people said, yep, this is very sweet.
This is loaded up with sugar.
And very, very sweet.
But then this other group of people said, yeah, okay, it's sweet, but it's also bitter.
I'm confused here. It's sweet and bitter. Bittersweet.
And that's the group I fall into. I find stevia, yeah, sweet, but also horribly, horribly bitter as well. So some people find stevia sweet, and others, like myself, find it sweet and bitter. And then things got even more strange, because in a different pot of coffee, I added in a different kind of artificial sweetener, ACE K, asulfam potassium. It's like people just traded places, right? So the group that said stevia was sweet, not bitter, just sweet, now they're telling me that ACE K, this different type of sweetener, it's also bitter.
This is more bitter than the last one, for sure.
And then the other group of people who found stevia horribly bitter and sweet, now the bitterness disappeared, and it was just sweet.
Too sweet.
What on earth is going on? Now, I got the idea for this test when I spoke with Professor Helena Hopfer.
I'm an associate professor in the food science department at Penn State.
And she suggested I do that experiment because it shows that, genetically speaking, the receptors on your tongue are different to the receptors on my tongue.
John Hayes, my colleague here, he has shown that bitter taste receptor TAS2R31 is activated by certain non-nutritive sweeteners, where people get the sweetness, but they also, depending on their genetic variant, might get quite some bitterness from it too.
So yes, genetically speaking, you and I might have different taste receptors. We might be drinking the same thing, but it literally tastes different to you and me. And it doesn't stop at the receptors in our mouths. There is also genetic variation in the aroma receptors in our nose. For example, Mandy Naglic, professional taster and author of the excellent book How to Taste.
One that I talk about in the book is beta-ionone, the scent of violets.
She told me about violet.
You could obviously live your whole life very happily without ever being able to smell a violet. You would never know. There's about a third of the population who can't smell that compound.
You and I could be drinking the same coffee, and I could say, ooh, I have a nice note of violets. And because of your genetics, you're never going to know what that smells like.
No matter how much training you do, if you don't have the gene for beta-ionone, you're not tasting it.
So, genetically speaking, your receptors are different from mine. But how big is that difference? And to get an answer, I spoke with Joel Mainland of the Monell Chemical Sensor Center.
On average, when we looked at these receptors in the lab, we found that about 30% of yours are functionally different from mine.
And when he mentioned 30%, I was like, oh my lord, that's enormous. If we were talking about color, that's like I'm looking at a wall and I say it's painted blue and you say it's painted red. However, Joel went on to explain that actually it's not that dramatic.
So there's a lot of difference at this sort of low level for specific compounds. But once you get to sort of complicated mixtures, it blends away a little bit. So your perception of something and my perception of something will be different, but usually not dramatically different.
So, although there are cases where one very specific aroma, like the aroma of violet, you might be able to smell it and I just can't. But the thing is, most aromas we encounter are really complicated. There's a whole mixture of different sorts of aromas all coming together. Like, take the example of coffee. Coffee is not just one specific aroma.
You have these nutty notes, these pyrazines that give you the nutty notes. You have different esters that add these fruity notes to it.
There are so many different types of aroma within coffee. And so when we breathe it in, they trigger a suite of different receptors, not just one receptor. And even though the aroma receptors are different in my nose compared to you, our brains get enough information to be able to say, okay, yep, you and I, we can both agree, this coffee is fruity. However, it could also be the case that, in that coffee, you might have this really distinct smoky note coming through. And that specific aroma I may not get because I just don't have the receptor for it.
At the same time, you might have individuals who think the coffee is very smoky and another person thinks it's not very smoky at all. And that might be just some genetic difference.
And what I find really weird about this, that smoky note, it is absolutely there in the coffee. And it's also not there in the coffee. Both are true at the same time. It just depends who's tasting it. It's really trippy to think about. And I start to wonder, how do we come together as a society, as coffee lovers, and say, this is what this coffee objectively tastes like? And the way that Joel gets a handle on what's going on here is he gets as many people in a room as possible, taste the same thing, and then look at what the average flavor experience is.
If you have around 15 people on the panel, they will look about the same as another panel of 15 people.
And so what Joel sees is that, on average, our experiences of a coffee are the same, on average. So, zooming out, do genetic differences in our receptors explain why I got such a variety of responses to that same coffee? And after exploring it this far, I've landed in a place where, on the whole, we do broadly perceive the same thing. But there are subtle differences, and sometimes quite major differences. The analogy I use is, imagine you and I were staring at a white wall. I say it's more of an eggshell white, slightly warmer. And you say, to me it's a bit cooler, it's more like snow reflecting a blue sky on a winter's day. You and I, we both see this wall as white. They're just slightly different shades of white. And then our friend walks into the room, stares at that same wall and says, this wall, it's a white wall, but it's got this distinct green sheen to it. You and I look at each other and we're like, okay, well, we don't see that, but who are we to tell you what you are seeing? If this were a coffee, you and I, we say, yeah, this is a medium roasted coffee. It has notes of chocolate. And along comes our friend and says, I'm getting a distinct smoky note. We might not taste it, but we can't deny that our friend is experiencing that smoky note. Now, I have also come to the conclusion that genetic differences alone do not explain how I can give the same coffee to many different people and they give me such a crazy array of flavor notes. No, there must be other things going on. And so next, we're going to explore cross-modal effects, how our environment shapes what we're experiencing. So, the second question I explored was, when you and I drink the same coffee, was there something in our environment, what we saw, what we heard, what we felt, that changed the flavors of the coffee? And back in Athens, at the Marco Beverages stand, I tried out another experiment. I used the same bag of coffee and brewed a few batches of filter coffee using the SP9. Part 1 of the experiment, I just gave this coffee to my taste participants and asked them, what does it taste like? Now, the coffee itself was a high-scoring, naturally processed red bourbon from the Café de Mama's Women's Project in northern Rwanda, roasted by my favorite roasters here in Berlin, 19 grams. And as predicted, everyone said, yep, it's quite lovely.
That's nice. That's very good. Definitely a lot of fruity notes.
I get sweetness, not much bitterness.
Then came part 2. I asked them to put on a pair of headphones. Then I played them some super angry, intense rock music. And here's the thing. A lot of my taste testers suspected they were tasting the same coffee.
Are you giving me the same coffee?
But despite that, the music changed their perception.
It's more bitter than the previous one. I mean, it might be the same one, but the music is making me angry.
I feel like the bitterness is starting to cancel out the sweetness a little bit.
And a couple of the taste testers, like Miroslav, were fans of this royalty-free track that I just plucked off the internet.
Yeah, it sounds like my playlist.
Oh, really?
You like this music?
So, angry rock music, no surprises. Coffee tasted more bitter. This is an example of a cross-modal effect, how one of our senses affects the other sense. For example, what you hear affecting what you taste. And I was inspired to do this rock music experiment after I spoke with a well-known cross-modal researcher.
So my name is Janice Wing.
She's an associate professor of consumer psychology at the University of Copenhagen. And she spoke about some experiments she did looking at music and how it changes what we're tasting.
I'll just give you one example.
In one experiment, she gave participants this juice that was both sweet and sour and asked them to put on a pair of headphones.
They heard a little melody that was either harmonized with consonant interval or dissonant interval. And what we found was that the fruit juice tasted more sweet when they were listening to the consonant music. And the juice tasted more sour when they were listening to the dissonant sound.
And Janice's theory is that
we associate sweetness with pleasant emotions and sour and bitter with unpleasant emotions.
Music stirs our emotions, which can lead us to focus on different aspects of a complicated drink, like coffee, which can be at the same time bitter, sour, and sweet. And when I think back to that tasting experiment at the Athens trade show, the Marco Beverages stand where I did the tastings, they were very close to a coffee competition stage. And you could hear the music from the stage. Could that have influenced what people were tasting? And here's another thing too. In the last series, I showed you a study done by Felipe Reynoso, where he asked people to put on these headphones and he played very loud cafe sounds, like up to 85 decibels. And the majority of the participants told him that their coffees tasted more watery. And here we are in this loud environment nearby a coffee competition stage. Was that making people's coffees taste more watery? Or stronger? Because about 20% of his participants said when they were listening to very, very loud cafe sounds, the coffee was more intense. they tasted more sweetness, bitterness, and acidity. So you have more than half the group saying that coffee tastes more watery, but there's a proportion of people, 20% or so, who say actually, we think coffee tastes more intense in a loud environment. Sound influences different people in different ways. And these cross-modal effects, they go well beyond sound. You know, even the shape of the coffee cup can influence what you taste. And I learned this speaking with Brazilian researcher Fabiana Cavallo of the Coffee Sensorium.
And I am a neuroscientist. I've been doing research in neuroscience for 23 years.
And I want to tell you the story of a really interesting experiment she did in 2017.
On how the cup would affect the perception of coffee.
Now, in the world of wine, this is a very well-known phenomenon.
So there are lots of articles that demonstrated that the shape of the wine glass can affect the way people perceive the wine.
But does that same effect translate in the world of coffee? So for this test, Fabiana needed different types of coffee cups. And she went clicking around the internet and came across a highly respected specialty coffee roastery in Norway called Tim Wonderbo, founded by a man of the same name. And Tim and his team had designed these quite unusual looking coffee cups, which they said would bring out different attributes in a coffee.
So these cups should be used for more acidic coffees. These one should be used to sweeter coffees.
And I want you to picture two of those cups. The first was shaped like a tulip bulb.
Bulbous cup, wine glass shape.
Wider at the base and then getting narrow towards the top. So that's the first cup. And the second cup is what Tim Wonderbo called the split cup, because it resembles an hourglass.
So it's a cup that has an indentation in the middle.
So we had the tulip bulb cup and the hourglass cup. And on the website, Tim Wonderbo stated that the cup that looked like the tulip bulb would be good for enhancing sweetness, and that hourglass shape, the split cup, would be better for enhancing acidity. And Fabiana was a bit curious. What kind of tests had Tim and his team done to make these claims?
So he replied to my email saying that, well, we did some in-house testing, with my team, so around 6-7 people.
With so few people doing the test, Fabiana wasn't convinced about these claims.
So it's not really a scientific sampling size, and also biased because they participated on the development of those cups.
Now, Fabiana had plans to visit a coffee trade show in Brazil.
And then I asked him if he would be willing to put those cups into test, actual test, with hundreds of people. And he said, oh, absolutely.
And so these cups, which had been developed in Norway, made their way to Brazil. And Fabiana got some rather intriguing results.
But what we observed was that the bulbous cup, it enhanced the aroma perception.
So the cup that looked like a tulip, the classic kind of wine glass shape, for Tim and his team, it enhanced sweetness. But Fabiana's participants said it enhanced aroma instead.
And that was how our hypothesis in the beginning, because it's very similar to a wine glass shape.
And then regarding the hourglass-shaped cup, Tim's team for them said it increased acidity. And for Fabiana's participants, it too increased acidity, but also sweetness.
The coffee was perceived as sweeter and more acidic when tasted from the split cup.
And so Fabiana discovered that, yes, the shape of cups do influence your perception of a coffee. But for her participants, not the same way that Tim and his team had described it. So, those sound experiments, the cup experiment, they're just some of the many ways in which our environment affects our perception of a coffee. But going back to that tasting at the Marco stand, where my participants gave me very different descriptions of the same coffee, these cross-modal environmental effects, how big of an effect do they really have? Going back to my white wall analogy, are these cross-modal effects big enough that, I'll look at a white wall and say, that looks white to me, and you look at it, and you say, white? No way, that wall's blue. So here's the thing. In Fabiana's experiment,
The difference, they were statistically significant.
She had low p values, which is a good thing, because it means that there's a very low probability that the result she got was just from random chance. But the issue is more the size of the difference. I mean, it's not nothing, but it's not earth-shattering either. For example, she found the differences in the intensity of aroma, they went from level 5 to level 6 on a 10-point scale. And that's roughly the same level of change that I saw in Janice Wang's sweet-sour music experiment. Like I said, it's definitely an effect, but it's not night and day either. So going back to those very different responses I got to the same coffee.
It's sweet.
This is quite chemically.
There is a bit of orange taste, orange peel.
Maybe something green.
Dark chocolate.
Almost tea-like.
Woody astringent finish.
How much of what we've just learned explains these differences? Genetic differences between my receptors and your receptors? Okay, yeah, there's a small difference there. Cross-modal influences and things in the environment that affect us all differently? Yep, there is a small effect there too. But both of those combined don't explain just how dramatic the differences were in what flavors people were experiencing. And so, I continued looking around and then came across another possible explanation. So, the third explanation I investigated for why I was getting such a wide range of responses to the same coffee is differences in our lived experiences. This is a very, very broad category, catches a lot of different things, but it boils down to the fact that I have lived a different life to you. Everything that I've experienced and learned in my life and how that's wired my brain is going to be different to you.
And now, as a thank you parting gift, can I offer you...
And to show this effect, I did one final experiment at the Marco Beverages stand in Athens. One morning, while I was waiting for the bus to take me to the convention center, I dived into a local Greek supermarket and I picked up a bottle of local liquor, 40% alcohol. This thing had a punch. And then at the end of my tasting experiment, I gave each participant a shot of this alcohol. And for some of my taste participants, like Bram...
Yeah, I like it. Lovely, yeah.
Honestly, he could have been describing a dessert.
Elderflower, citrus, heat sweetness. Super, super nice.
However, for another taster, Carolina, she's someone who doesn't drink very often, and when she does, sticks to a light sweet mojito.
Oh my God, what is this? This is like vodka times 3. This is like pure alcohol. What are you giving me, James?
She could not get over that alcoholic punch.
Okay, thinner. There you go. That's what it is. I'm poisoned.
So how is it that Bram drinks this, tastes elderflowers, citrus, and then Carolina tastes it, and it tastes like paint thinner? She just can't get over the alcohol. Now, I got inspiration for this test when I was speaking with Professor Helena Hopfer, and she was mentioning to me some research done by Ilya Kroimans.
She's a linguist, and she compared the linguistic expertise of coffee tasters and wine tasters.
So the experiment had 3 groups of people: wine experts, coffee experts, and regular consumers. And they each drank coffee and wine and were asked to name all the different flavors they were tasting.
And found that coffee experts were really good at pulling out small differences within their products. But once they were faced with wines, they weren't so good. They were just like an average consumer. And same for wine experts as well.
The coffee experts were really great at saying, yeah, this coffee has got aromas of cacao and blueberries and a hint of tea. But when it came to wine, the coffee experts were like, yeah, tastes nice, kind of fruity. And the same thing happened with the wine experts. They'd drink wine and be like, oh yeah, delicious. It's got these notes of elderflower and jasmine, ripe apples. And then they taste the coffee and be like, yeah, it's nice. It's a fruity coffee. And so going back to the hard alcohol.
Elderflowers, a lot of elderflower, citrus, heat sweetness.
Bram was getting all these flavor notes because compared to Carolina, he's an expert. He savors spirits on a regular basis. He even has a certificate from a rum tasting course he did almost 10 years ago. Carolina, on the other hand, has no knowledge of the product. So what Bram has that Carolina doesn't is a language. A language around flavors for spirits, which he has spent a lot of time learning. So reflecting back on my tasting experiment, where I got a whole range of different responses to the same coffee.
Sweet.
Chemically.
Orange.
Green.
Dark chocolate.
Tea-like.
Woody astringent finish.
One reason these responses are so wildly different is because some are more expert at putting names to flavors than others. So that's one explanation. Moving on now. Another reason that could explain why those flavor responses are so different is because you and I grew up in different places. And I got this insight when I spoke with a coffee tasting expert.
My name is Frida Yuan. I am the 3 times UK cup tasting champion.
Frida is from Taiwan, but now lives in the UK. And she told me a story about how when she came to the UK as an adult, she worked in coffee, and she'd see like a flavor description on a bag of roasted coffee, and it would say blood orange. But the thing is, blood orange is very hard to come by in Taiwan.
So for me personally, again, never tried blood orange before I come to UK, so I never really know how it should taste like.
So you probably have tasted foods that I have never tried. And when I encounter hints of those aromas in a coffee, you'll be able to name it, and I'm going to struggle. Now, another thing that might be going on too is that you eat apples, I eat apples, but maybe our apples don't taste the same.
My apple from Taiwan doesn't mean it tastes the same as your apple here in UK. Doesn't mean, the terroir is the same. It doesn't mean it should taste the same. And so therefore, it's really, really hard to really put down a word saying this coffee tastes like apple.
Now, fortunately, this problem is solvable. Joel Mainland from the Manel Chemical Sensor Center told me about how he calibrates everyone so they have the same words for the same flavors.
When we train people to be panelists for us, we do sort of about 4 hours of training. And in that training, we'll give them a kit of reference odors that they'll use to sort of learn what these words actually mean. So when I say green, what does that mean to you, right? The green smell, here's a jar that has a green smell in it. You learn very clearly what the correspondence is between the word that you're using and what's in the vial.
I began this journey wondering whether indeed, if we taste the same coffee, are we actually having the same flavor experience? And this is where I've landed. There's a good chance that you and I will broadly taste the same things in the same coffee. But sometimes there will be a flavor in there that you pick up on, which I won't, which could be down to our genetics. Cross-modal effects and how, the same sort of background noise or music or the cups we're drinking affect us differently, it has a small effect as well. And I think the differences in our lived experiences, how expert we are at putting names to different coffee flavors, I think that explains most of the differences in the terms I was hearing when people describe the same coffee.
It's sweet.
This is quite chemically.
There is a bit of orange taste, orange peel.
Maybe something green.
Dark chocolate.
Almost tea-like.
Woody astringent finish.
Maybe the craziest thing of all is that coffee, it can be all those things at once, which is one of the many reasons I still love working in coffee. It's just so fascinating. Now, all the reasons I've covered in this episode for why people can use such different terms for describing the same coffee, there are many more reasons too that I haven't had time to cover, and I would love to cover them in a future series. And one thing I haven't touched on today, but it is so foundational to coffee, is preferences. Why do people like one coffee over another coffee? What even is quality? I invested a couple of weeks trying to answer that question for this episode, and I decided, no. This is a huge task. I'm going to leave it for the next series. However, in this series, in the next episode, I'm going to be covering the weird, wonderful chemistry taking place inside our roaster. How you turn green beans brown and where flavors come from, chemically speaking. And I cannot wait to share it with you. So, thank you for joining me on this metaphysical exploration. If you enjoyed this episode, one thing you could do that would mean a lot to me is share it with your friends. Take a screen grab of you listening to the podcast, post it as a story on Instagram, tag me at Filter Stories Podcast, and I'll repost it and I can say thank you. Now, on my Instagram, I have some behind the scenes shots of the coffee tasting I did at the Marco Beverages stand in Athens, including one of Miroslav listening to his favorite angry rock music. And you can see for yourself how I set up the tasting. So if you want to see that, follow me on Instagram at Filter Stories Podcast. There's also a link in the show notes. And now, here's what's coming next in this series of The Science of Coffee. I'm going to explore the science of roasting, the place where so many of coffee's amazing, delicious flavors are created. And to see for myself how beans transform from green to brown, I visit Roost. They're a Norwegian company who are developing fully automatic coffee roasters. And I take apart the machines to see the technology inside them that enables anyone to roast really good coffee very easily. Even I managed to roast coffee on the Roost machine. Then I go to Honduras and attend Let's Talk Coffee, a gathering of farmers and coffee professionals from across the world organized by Sustainable Harvest, a coffee importer. And it's there I get my mind opened to why organic farming is so much better for the environment than conventional farming with agrochemicals. And it leads me to the question, why don't we see more organic farms? If it's so great and all. And I answer that question by looking at the story of one of the most successful organic cooperatives in Honduras, Rouse, and how they managed to overcome so many hurdles over decades. Then we go deep into science itself, and I show you how I have been on a journey to begin thinking like a scientist. I get schooled on good scientific methodology. And my journey was made possible by BWT, Water and More. They make water filtration kits for coffee brewing at home and in the cafe. And me learning the science of water helped transform me from a quite naive coffee professional to a much more critical home scientist. And then finally, I show you how you can store and grind your beans to get the most exceptional flavors from them. I get really geeky with the technical experts inside Malkönig, an industry leader in coffee grinders trusted by baristas globally. And I visit their R&D lab to discover how grinders work and why it is that such a tiny, tiny change can lead to dramatically different coffees. The Science of Coffee was produced by me, James Harper, and I also write and play the piano music. I want to give a super special thanks to my wonderful taste testers. They are Abby Manning, Miroslav Orchenash, Manos Athanatos, Jeff Dow, Emmanuel Diaz, Carolina Pirola, Callum Gilmore, and Bram DeHoog. Thanks so much for listening. Happy tasting, and I'll speak to you next time.